Hey everyone! So here's a thought that might just blow your mind a little. Everything you see, everything you touch, everything you think of as solid is almost entirely empty space. So today we are diving deep into the illusion of solidity to figure out, well, how that's even possible.
And this really is the central mystery, isn't it? If atoms are 99.9% nothingness, then what's stopping you from just passing straight through a wall, or your hand from going right through your desk? It feels like it should be easy, but the physics behind why it's not, well, that's where things get really fascinating.
So, to really get to the bottom of this, we've got to start by understanding the paradox itself, the paradox of solidity and this idea of the empty atom.
To really get a sense of the scale of this emptiness, try this on for size. Imagine you could blow up a single atom to the size of a giant sports stadium. The nucleus, where pretty much all of its mass is packed in, that would be a tiny marble sitting right on the 50-yard line. And the electrons, they'd be like a few grains of sand zipping around the nosebleed seats. Everything else is just that so-called empty space.
But, and this is the first huge clue in our mystery, that empty space isn't actually empty at all. Not even close. It's buzzing with energy. It's filled with a powerful, invisible electromagnetic field. And that field, that is the absolute key to solving this whole thing.
So how in the world does that field work? Let's zoom in and take a closer look at the atom's force field, because it all comes down to one thing: repulsion.
You see, those electrons whizzing around aren't like little planets in nice, neat orbits. That's an old way of thinking. Instead, they exist in what physicists call an electron cloud. Now, don't think of it as a hard shell. It's more like a fuzzy, blurry cloud of probability, the region where the electron is likely to be. This cloud is what gives the atom its size, and crucially, it acts like a powerful, invisible, repulsive barrier. Okay, so here is the really mind-bending part. When you press your hand against a table, the atoms in your hand never actually touch the atoms in the table. Nope. Not at all. What you perceive as the feeling of solid is the immense electromagnetic repulsion between the electron cloud of your atoms and the electron cloud of the table's atoms. You're feeling force pushing back against force. You've never truly touched anything in your entire life. Wild, right?
Okay, so that force field repulsion explains why we can't just pass through stuff. But what stops all the atoms in the table from just flying apart? To get that, we need to look at what holds it all together in the first place: matter's atomic glue.
See, in a solid object, the atoms aren't just floating around freely. They are locked into fixed positions. They're held in place by incredibly strong chemical bonds, which are formed when atoms either share or transfer their electrons with their neighbors. This whole process creates a rigid, highly ordered structure. Think of it like a microscopic scaffold or a crystal lattice, and that is what gives a solid its definite shape and volume.
So, if it's all the same basic principles, how do we get things that feel so totally different? Like soft skin versus hard bone. Well, it all comes down to the architecture of texture.
Let's just take a look at our own bodies. In our skin, you've got these flexible proteins like collagen and elastin, and they're all arranged in a kind of loose basket weave pattern. That's what makes it pliable and soft. But bone, that's a whole different story. There, you have a super dense crystalline lattice of minerals, like calcium, built around that same collagen foundation. That's what makes it so incredibly rigid and hard. So you see, it's the same atomic rules, but a totally different molecular design gives you a completely different sensation.
All right, let's take this one final, mind-bending step further. I want to ask a really strange question. We're going to explore what an atom's true surface really is.
This just raises a fascinating question, right? What is the texture of one single atom? I mean, if you could somehow feel it, would it be smooth? Would it be rough? What would that even mean at that impossibly small scale?
And the incredible answer is, concepts like smooth or rough just don't apply. They're meaningless at this level. You can't touch an atom's surface because it doesn't really have a physical surface. An atom's boundary is defined entirely by its force field.
So if it's not a physical texture, what is it? Well, the best way to think about an atom's texture is to think of it as its chemical reactivity. Let's take a noble gas like neon. Its outer electron shell is full and perfectly stable. It doesn't want to react with anything, so you could say it's chemically smooth, it's non-stick.
But then you have a highly reactive element like oxygen. Its outer shell is incomplete, which makes it sticky. It's actively on the hunt to bond with other atoms. That's its texture.
Okay, let's put this all together and recap our journey. We started with this idea of empty space, which we now know is actually buzzing with force fields. That feeling of solidity is nothing more than the electromagnetic repulsion between those fields. The structure of the world around us comes from atoms linking up through chemical bonds, and the texture we feel, hard, soft, you name it, comes from how those bonded molecules are arranged. And at the most fundamental level, an atom's surface isn't physical at all, it's its chemical personality.
Which leaves us with one final, pretty profound thought to chew on. If solidity is just an illusion created by these competing force fields, and you never really, truly touch anything, then what does it mean to experience the physical world at all? Thanks for joining this explainer.